Okay, so now we're going to look at the summation notation for the area under the function f. F is right here, x cubed minus 2x squared minus 5x plus 11. On the domain negative 2 is less than or equal to x is less than or equal to 2. But we're actually going to write this in a kind of a more generalized way, so that'll be easier to change things around if we decide to change the domain, if we decide to change whether we're going from the left-hand side rectangles or whether we're using the right-hand side rectangles. A really nice idea to get started is to think to yourself, based on what your width is, if you're going from negative 2 to 2, how many rectangles is that? In this situation, everything is 4 rectangles on both sides. Now, these rectangles all have a width of 1. I'm going to keep the width 1 for today, but do know that the width could change. We'll talk about reasons why we might want to make the width smaller, how that could help us to get more accurate answers. So today we might feel like the multiplying by 1 feels unnecessary. But of course, when the width is not 1, multiplying by 1 is going to be extremely important. Now, when we make our summation, we talked about the other day in class that we can add up all of the heights of our rectangles, and we can add first, and then we can multiply by the width since they're all going to have the same width. So the width is going to be out here, and we're going to add all the heights first. And that comes from the distributive property. So we can add before we multiply since they're all getting multiplied by the same number. So that's important to remember in general. Just want to get rid of this because it'll be in our way later. Okay, so let's talk a little bit about how we could plug this in. So instead of writing in the whole entire function, just because that takes a lot of work, I am going to just say that I want to plug things into f of, and I'm actually going to use, instead of starting at negative 2, I'm going to say we're just going to plug in n minus 2. So we're going to take the number and we're going to subtract 2. And the reason that I do that is because then I can move this number around based on where my domain starts. So here my domain starts at negative 2, but if my domain started at 3 or 4 or 7 or negative 5, I can always just mess with this number to show where the domain starts. So that's kind of where we get started. Now, where this ends is based on the number of rectangles. So if this is the rectangle that happens when we plug in 0, since 0 minus 2 is going to give us negative 2, this is when we plug in 1, this is when we plug in 2, this is when we plug in 3, 3 minus 2 is 1. That is where we're going to end at 3. And 0 to 3 is 4 rectangles because we're including 0 in our count here. So we plug in 0, 1, 2, and 3, and that gives us the 4 rectangles with the left-hand side. And that's it, we're finished. If we wanted to do the right-hand side, all we would have to do is we have the same width. We're starting in the same place. We have the same number of rectangles. However, I don't want to start by plugging in 0. If I started by plugging in 0, I would go to this point here. I'd actually not go to that point there. That's a lie. If I started by plugging in 0, what I want is that point there. But if I plugged in 0, it would give me the value of this point right here, which is not a point I want at all. That doesn't give me the height of anything. So what I want to start is by plugging in 1. All right, same thing we did for the left-hand side, right? This is the height of our first rectangle. So now instead of starting at 0, we're going to start at 1, and we're going to end at 4. So we still have 4 rectangles, 1, 2, 3, 4. So here we go from 0 to 3, and here we go from 1 to 4, which gives us the same 4 rectangles. Like I said, what's nice about this is if we wanted to change where we were starting from, we just change this number here. And if we wanted to change the number of rectangles, we would just change here. Okay. Changing the width is going to require just a teeny bit more work, and we will do that in the coming weeks.